Good morning. It's an absolutely lovely Thursday morning. It rained last night, and the streets now have a clean, fresh look. And it's the start of a new and relatively busy day. Today, we are setting up for a new project for this quarter for our client. It's a backend Java application, a web service that they'll be developing. There's some old code that they have, code base that they have, but it's fun. But for the most part, it's a new project, and we're getting set up on that project this week. So normally, I would say getting started with Java development, if you're an individual developer, is not a big deal. Just download the SDK and get started, and you're good to go. Use your favorite IDE, and you're good to go. However, if you're starting a project that's going to be developed on and worked on by more than 3 or 4 people, then it makes sense to follow and ensure some consistency in your setup process. So for this particular project, we have about 7 developers with a mixture of machines. A couple of them are using Windows machines. A couple are using Ubuntu desktops. Our server environment is on CentOS, and it's in the cloud. It uses CentOS in the cloud, and there's one Mac OS development environment. So we need to ensure that the application can be built on and run on all of these environments. In addition, it is a backend for an Android mobile application, and so some of the developers, especially the Mac OS developer, will be using both. Will need to run the backend while during development on their own machine inside a virtual machine, and they will need to set up they will need to do their own Android development. There's also going to be an iOS client for this backend, so this iOS application will also be developed. And of course, that's always on the Mac. So the process of setting up and making sure that we have a consistent environment across development environment across all these machines for all these developers is a bit of a challenge. And additionally, we have a couple of offshore developers who are doing outsourced development and stuff on some aspects of the code, and so we need to give them a consistent access to a consistent environment too. So for today's blog, I'm just going to talk about setting up Android and some of the gotchas. Think of it's mostly more notes to myself than they are to the general public, but hopefully if I found it useful, hopefully you will find it useful as well.
Okay, let's get started. From the perspective of DevOps, you need to consider 5 things when you get set up for Java Web Services development. First, you have to choose the JDK version and distribution. Then you have to choose the package management system that you're going to use on each operating system to deploy your chosen JDK version and keep it up to date. Then you have to choose which build system you plan on using to build your application. Is it Ant, Maven, Gradle, or some other homegrown system? Then you need to settle on which IDE you want to use, or if you want to allow a free choice of IDEs amongst team members. Finally, you need to decide what web services framework you're going to use to develop your application. Okay, now let's look at the choice of JDK version or JDK distribution. Traditionally, the choice has been rather straightforward. You go with the Oracle JDK, and you wouldn't be making any mistakes, and it would work properly. However, Oracle has changed its licensing policies in 2019, and now it ceases to offer support for most free versions of the JDK within about 6 months of release. Um, and so this may not quite suit you for production deployment. The alternative is to use one of the many OpenJDK builds that are available. The most popular one, and the one that I think I would recommend if you're a startup or a department within a larger organization, is to go with Adopt OpenJDK. This is an OpenJDK build that is maintained for a much longer period than Oracle maintains its build, and most closely resembles the old maintenance schedule for long-term releases. So particularly if you're using Java 8 or Java 13, then the Adopt OpenJDK build is a good choice. If you are working entirely in a single operating system like Red Hat, then you're probably better off choosing the Red Hat implementation of the OpenJDK. There are other options like Azul and IBM's OpenJDK build, and you will choose these depending on specific use cases and needs. How you deploy applications to production or to development and testing environments will be determined by which form of package management is best suited to managing your JDK installation. For Linux distributions, it almost always makes sense to use the OpenJDK package that comes with the package manager, yum, DNF, or apt. Historically, Mac OS was not a very friendly environment for Java development. That hasn't been the case anymore for at least 10 years on Mac OS. On Mac OS, you should consider using either MacPorts or Homebrew to manage your Java installation. I've seen people use SDK Man as well. I'll explore the pros and cons of various package managers in a future blog post. On Windows, if you're using Adopt OpenJDK, I suggest you simply go with the installer MSI. The zip file may result in you installing the JDK in a location that you then forget, and then updating the JDK becomes more work. However, in both cases, there is no auto-update feature available, so you need to update your copy of OpenJDK manually, although there does seem to be some thought about developing an automated update feature for Adopt OpenJDK. SDK Man would be an option in this scenario, although I have not explored its use on Windows. I'll write a blog post about it when I do. The last option is a manual install of the JDK. I would avoid this to the extent possible unless there are strong organizational reasons for you to do so. If you install the JDK to a custom location, your developer team may not find the JDK and proceed to install their own version of it, thus destroying your attempt at standardization. There are other problems that can crop up. So on the whole, I would not recommend a manual install. But if you have no choice, go ahead and do it. For any reasonably sized project, invoking Java-C is not going to be sufficient. You need to use a build system. For Java Web Services, the options are essentially Gradle or Maven, although for some really old code bases, I've seen Ant used as a build system. If you have the ability to choose your build system, go with Gradle. It is substantially easier to understand and use. It is also faster, although not significantly enough to merit much consideration unless you have a really massive code base with huge numbers of dependencies. In particular, if there is any Android development involved, Gradle should be your default choice. The latest versions of Gradle give you a choice between using Kotlin or Groovy as the DSL, that is the domain-specific language, to use in specifying build files. As of 2019, though, I would recommend that you still use Groovy as your DSL, even for projects where Kotlin is the development language. Kotlin DSL support is still new enough that I would wait for it to mature before using it in projects that you deem important. As for the choice of IDE, I have no strong recommendations here. My personal favorite IDE is IntelliJ's IDEA's Ultimate Edition. I find it intuitive and extremely helpful with new features of the Java language. It is, however, pricey, but usually for a professional developer, the improvement in productivity should compensate for the cost. Your mileage may vary. Eclipse is probably the most popular IDE. It is free and has a huge ecosystem of plugins. If you're new to the IDE, however, it may take some time to get used to the quirks of Eclipse. The third common IDE that I see around is NetBeans. Its popularity arose from the time it was shipped as the default IDE for Java 8. It is no longer part of the official JDK, but it is still reasonably popular. Finally, I noticed that developers are more frequently using Visual Studio Code as an ad hoc environment in which to edit Java files. From the perspective of a DevOps team, there are a few things you should consider. First, whether you want to standardize on one IDE or let developers choose what works for them. I'm in the latter camp. However, standardizing an IDE has some advantages. First, it allows the experience and knowledge of the IDE to be shared between team members. This can be a considerable advantage given how complex Java IDEs are. There is usually one member on the team that is a bit of an expert in the IDE, and having just one IDE used in the team will allow that expertise to be shared. If your development team is inexperienced, I would strongly recommend standardizing on a single IDE. On the other hand, if you have an experienced team, it's best to leave the choice of IDE to the developer and let them use whatever IDE suits them and makes them most productive. The next thing to consider is IDE-specific builds versus Gradle or Maven projects. Many inexperienced developers, particularly those with experience of programming entirely within the IDE, and this is quite common amongst Java programmers, will often start a project using the IDE's build system. This can become a problem when you need to build a robust deployment pipeline, since the automated builds will typically require Gradle or Maven, or at least Ant, to work correctly. At this point, the team will find the switch to a build system difficult. Furthermore, they would have almost certainly locked themselves into using a specific IDE. So it makes sense early on to insist on getting your build system set up correctly and having developers work with that build system while you still have the chance to set the build culture into the team. The next thing to consider is deployments from within the IDE versus a dedicated deployment system. All of the three big IDEs all offer automated deployment to an application server from within the IDE. This is extremely convenient for a developer. However, it is a double-edged sword. Early in a project, when rapid development is desirable, it makes sense to ship code directly from the IDE into a production app server. As the code base grows and the business starts becoming more dependent on the reliability of the application and the deployment pipeline, uncontrolled IDE-based deployments become a risk. My recommendation to a DevOps team would be not to hinder IDE deployments to dev and test application servers, while being more restrictive. Finally, we come to the choice of web services framework. The major frameworks I've seen most teams use include Java EE, Spring Boot, and Play. The choice of framework will mostly be a function of existing code and the development team's familiarity with the framework. From a DevOps perspective, it's probably best to avoid Java EE for new projects, and this will also usually be the same decision that your development team will make. Most new Java development projects probably go with either Spring or Play. And that's it from a DevOps perspective. Essentially, a little forethought can go a long way. It is trivially easy to get started writing Java code, but a little forethought on how you want to get your team to set up with a Java development environment can go a long way in making development, debugging, and deployment a pleasant experience, and most importantly, a profitable one. Happy coding!